All right, let's talk about a really fascinating new idea for AI. It's called Meta LLM. And look, this isn't about making AI bigger or faster. No, this is about changing how it thinks, or maybe more accurately, how it learns to doubt. So let's dive in and see what that's all about.
So let's start with a question that really gets to the core of this. We use AIs for everything now, right? Summaries, answers, creative stuff. But have you ever stopped to think, what if they're all just stuck in a giant echo chamber? What if they're just getting better and better at, well, repeating what they've already heard? The paper we're looking at actually has a name for this problem. They call it the Mobius loop. And it's a perfect metaphor, really. Think about it. An AI gets a question, it goes out, finds some authoritative source, irons out any messy contradictions, and spits out this super confident sounding answer. Then, guess what? That answer gets absorbed into the internet, becoming another source, reinforcing the original one. It's this perfect, self-contained loop with no way out. Okay, so let's get into the AI's echo chamber. This is the real problem, right? Current language models are amazing mimics. They're basically expert-level predictors of what word comes next, and that makes them absolute masters of sounding coherent, sounding plausible. But here's the kicker. Sounding right is not the same as being right. And right now, there's nothing in their design that actually pushes them to find out what's true. So inside this Mobius loop, you can see what's missing. These things on the screen, they should look pretty familiar. They're basically the core principles of the scientific method. AIs right now don't have to make explicit forecasts like, hey, if this is true, then we should be able to see X, Y, and Z. They don't have to identify what could prove them wrong. They're not forced to actively hunt for different ways of explaining things. They're built for obedience, to follow the pattern, not for actual inquiry. Okay, so how do we break this loop? Well, the Meta LLM idea is a three-layer cake, and layer one is all about changing the rules of the game. Let's dig into this thing called the ODA-I protocol. And here it is, the big shift in thinking. On one side, you've got obedience. That's the default mode for today's LLMs. Just continue the pattern. But on the other side, you have inquiry. And this isn't just a nice-to-have behavior. No, it's a strict protocol the AI has to follow. We're talking about building a system that is literally required to poke holes in its own beliefs. So how does this ODA-I protocol actually work? Well, it's a four-step process. First, the AI has to label its own answer. Is this a testable scientific claim, or is it more of a story, a narrative? And if it says, okay, this is scientific, it can't just drop a fact and walk away. It must give a forecast, state what could prove it wrong, a falsifier, and, this is huge, it must present at least one alternative idea. It's literally forced to argue with itself. Here's what's so smart about this first layer. You don't actually have to build a brand new AI from the ground up. The ODA-I protocol can just act like a control layer, a wrapper that you put on top of the LLMs we already have. It's like a coach that forces this discipline of inquiry onto the existing tech. All right, layer two. This is where things get, well, pretty wild. We're moving beyond a simple line of text. The idea here is to completely rethink how an AI even sees language, shifting it from a flat line into a complex 3D map using something called nested cube linguistics. So today's AIs see language as just a flat sequence of tokens. Think of it like beads on a string, one after the other. The AI gets really, really good at knowing which bead is likely to come next, but it has no real deep understanding of the string itself, the structure that holds it all together. But Meta LLM, it suggests something completely different. Instead of a line, imagine language as a path. You're walking through a rich, three-dimensional structure. Every single word, every sentence is a unique journey through this incredibly complex landscape. So what is this 3D space? It's structured as three nested cubes. Think of it like a set of Russian dolls. The outer cube, cube 0, holds the most basic symbols, like consonants. The next one in, cube 1, modifies them. Think vowels or changing a verb's tense. And the very core, cube 2, handles really abstract stuff like negation, flipping a statement's meaning. So a word isn't just a token anymore. It's a specific point located within this three-dimensional grid. And you might be asking, why all this complexity? Well, it's because to truly break free of that echo chamber, an AI needs a deeper understanding of language's logical bones, not just its surface-level patterns. Okay, so if language is a path through a 3D map, how do you measure that path? This is where a cool math concept called a Betty number, specifically beta 1 or beta 1, comes in. Don't worry about the term, just think of it as a simple way to count the number of logical loops in a piece of text. It's a tool that lets us measure how complex an argument really is. So we have new rules and a new map. Now for layer 3, a brain that can scar. The paper calls them urchin origami brains. And this is maybe the most radical idea of all, a memory that actually learns from being wrong. So, what does this brain look like? It's a theoretical structure called an unfolded brain lattice, or UBL. Forget the typical grid of neurons. Instead, picture something more geometric, a central ring with spokes shooting out from it, all covered by a kind of skin. The AI's actual thought process isn't just numbers changing, it's an activation pattern, a flow of energy moving across this unique scaffold. And here is the absolute game changer. In this model, when the AI hits a massive contradiction, when it's proven profoundly wrong, it doesn't just tweak some weights. No, the event creates a topological scar. It's like a landslide permanently blocks a road in its mind, or a new bridge suddenly appears. This scar physically changes the structure, altering how it can think in the future. It's basically learning from trauma. And that is the ultimate escape hatch from the echo chamber. Because once you have a deep, structural memory of being wrong, you're a lot less likely to confidently walk down that same failed path again. It forces you to find a new way. This quote from the paper just nails it. The system does not merely adjust weights, it reshapes its loop structure. I mean, think about that. Current AIs learn by making millions of tiny, subtle adjustments. This is different. It's about the system fundamentally rebuilding its own internal landscape. Memory isn't just stored data, it's a physical change to the shape of thought itself. So let's put all the pieces together into one big vision, building and inquiring AI. We have the rules, the map, and the memory. How do these three pretty abstract layers actually work together? Okay, here's the entire data flow from start to finish. A user asks a question, the O2I protocol grabs it right away and sets the rules. Then, the query gets mapped onto that 3D nested cube structure. That potential thought path is then checked against the AI's brain, the UBL, to see if it runs into any of those topological scars. The best, most coherent path is chosen, translated back into regular text, and then one last check. The O2I protocol makes sure the final answer meets all the standards of inquiry before you ever see it. Now, I know this all sounds like something straight out of science fiction, but what's cool is the paper actually lays out a pretty practical 4-phase roadmap. Phase 1 is just building that O2I protocol as a simple wrapper around the AIs we have today. Then you'd slowly add in the other layers, the new language map, the scarring memory, until you finally get to designing totally new AI architectures. So this isn't just a dream, it's a grounded research plan. And all of this really leaves us with one big, important question. What kind of AI do we actually want to build? I mean, the easy path is to keep building AIs that are designed to agree with us, AIs that are happy to stay in that comfortable echo chamber. But should we be aiming for something harder? Should we be trying to build AIs that are designed from the ground up to doubt?